In Lesson 3.2, we will be taking a look at graphing quadratic functions. There are different ways that we can graph quadratic functions. In this example, we're going to take a look at using the standard form. Now, as a quick reminder, the standard form is in the form f of x equals ax squared plus bx plus c. So you can see here that we have an equation that is in that particular form, where we have negative 2x squared plus 16x minus 24. And so from this we can identify the a, the b, and the c from our standard form equation. So the a is going to be this negative 2 right here. The b is going to be the 16 right here in front of x. And then the c is our constant term with the negative included, so a negative 24. Now, one of the key points when we're graphing a parabola, which is what we get when we graph quadratic functions, is the vertex. So in order to find the vertex, we need to start by finding the x-coordinate. And to find the x-coordinate, we can follow a formula, which is that the opposite of b divided by 2 times a is going to give us whatever the x-coordinate should be. So in this case, the opposite of b, well, my b was the 16, so the opposite of b is going to be negative 16. And then we've got 2 times the a. A was the negative 2, so we'll substitute that in for a. And I'm going to end up with negative 16 divided by negative 4, which is going to give me a positive 4 answer. Okay, so I know now that the x-coordinate of my vertex is positive 4. Now I need to find the y-coordinate that goes with that. And so for the y-coordinate, I need to go back to the actual function and find out what g of 4 is going to equal. So I'm using the 4 that I got for x, and I'm substituting it back into my g function here that I'm trying to graph. So that means taking negative 2 times 4 squared plus 16 times the 4 minus a 24. So if we start doing some evaluating, we know that 4 squared is going to be 16. 16 times negative 2 will give us a negative 32. Then we've got 16 times 4, which will give us a 64. And then we've got that minus 24. So when we add all this together, our two negatives would give us a negative 56. Negative 56 combined with positive 64 is going to give us a positive 8. So my y-coordinate here is going to be positive 8. And now I know where my vertex should be for my parabola. Also from this, when I use the x equals negative b over 2a formula, I also end up with what the axis of symmetry should be. So this equation of, x equals 4, that equation is my axis of symmetry. Okay, so using that information, we're going to now graph. So on our graph, we're going to start with the axis of symmetry, which we said was at x equals 4. Now remember, x equals a number tells us a vertical line. Axis of symmetry for parabola is always a vertical line. So at positive 4, I know that I have an axis of symmetry. And what that axis of symmetry does is it tells me where the parabola reflects. So I know that points that I have on one side of the axis will reflect to the other side of the axis, which makes the graphing a bit easier. Okay, I also know my vertex, which was the 4, 8. So on this axis of symmetry, which was x equals 4, I'm going to go up to 8. Try that again. 2, 4, 6, 8. Right? Okay, why isn't this wanting to write? Give me just a second, guys. Sorry about this. Using some new technology here, and it's not cooperating very well. Well, shoot. There we go. All right, so there's my vertex 4, 8. All right, so I've got the key point. I've got an axis of symmetry that tells me that one side will reflect on the other side. Now I just need to know what one of those two sides is going to do. So now I am going to make a table of values. And the x's that I choose for my table are going to be something around my vertex. So for example, since my vertex is here at 4, 8, I'm going to choose an x value of 3 because it's something close to the 4x that is in my vertex, and it's a relatively easy number to figure out. I'm also going to choose a 2. Okay, so when I put in 3 for x, excuse me, 3 squared is going to be 9, times negative 2 will be negative 18. Then I'll add to that 16 times 3, which is 48. And then I'll subtract a 24. So the negative 18 plus 48 is going to be 30. And then the 30 minus 24 gives me an answer of 6. When I do the same thing with 2, 2 squared is going to give me 4 times negative 2 will be negative 8. Add to that 16 times 2, which is 32, and subtract 24 from that. So the negative 8 plus 32 gives me a positive 24, and then I subtract 24 from that, and I get a y value of 0. So when I go to plot these points, 3, 6 is going to be a point that's right about there, and 2, 0 is going to be a point that's right about there. Okay, so now we're starting to see half of the parabola. We can see what the left side is going to start looking like, and it fits what we would expect because our a value here in front of x squared, since that's a negative 2, we would expect that our graph is going to open down, and we can see that that's what this parabola is going to look like. Now, the other thing we can also see is that with our axis of symmetry, I can just reflect the points to get other points on the other side. So the point 3, 6, if I reflect that and go one x value to the right of my axis of symmetry and go to 4, that's also going to give me an answer of 6. So I would get a point right there. Same thing with my point at 2, 0. If I go to 5 on the other side, that will also give me a 0 because that's going to be the reflection of that point. Okay, and the key to doing these graphing problems well is to make sure you always use 5 points. One of the points will be the vertex, and then usually you pick 2 points on the left and reflect them to the right, or vice versa. You can pick 2 points on the right and then reflect them to the left. And once you do that, then you should be able to draw your parabola through those points, and you've got a fairly accurate parabola for the equation g of x equals negative 2x squared plus 16x minus 24. All right, so that gets us a start on graphing. When you come to class the next time, we'll continue with our graphing lesson and talk about more methods for graphing quadratic functions. We'll see you then.